Hello, I hope you've been well. Since my last video, I've had some annoyances with my SolidWorks license, and I've had to stuff around a little bit to get a version of SolidWorks that actually works. So I've had to sort of postpone my development of the CAD side of things for this project for a little bit. I believe I have access now. I still need to muck around with it just to get it finalized, but so hopefully I should be able to continue with the CAD stuff soon. But for now, I've been working on some coding stuff to get the actual brain that will control the position of Jugglebot working properly. And so in this video, I want to go over what my current working for that is and what I'm going to be doing in the near future to sort of finalize this function. So I'll give a brief overview of what it is in very high level terms, just so that if you are just sort of following along with this project and just sort of curious, that will hopefully satisfy your curiosity. And then I also want to go into a little bit of depth on how I'm actually going to be doing this with code. And it's yet to be seen how well I'll be able to explain this, but I'll give it my best. So without further ado, let's get into it. So the overall goal of this function that I'm writing now is to have it set up so that I can just put in a number, like a height, and the Jugglebot will throw the ball up to that height. So if I put in half a meter, it will throw the ball up half a meter. So the overall input for this function will be whatever height I want to throw the ball to, and then the output will be that the motors will move in such a way that it will do that. That's the general gist of what I'm trying to do. Now, actually doing this is a little bit more involved, as anyone who has experience with coding will probably know. So if you're not too interested in those details, then I am totally understanding of that, and I will see you in the next video. And I hope you have a good one until then. But if you are interested in how I'm actually doing this and what I've done so far, then you should stick around. What I've done to achieve this goal of throwing the ball to a desired height based on whatever number I put in, and then that's it. That's all the user will actually see. The way that I've done that is to actually set up 5 functions. So the first function will calculate the velocity that I need to actually throw that ball at, and then also at the same time it will calculate the velocity that the ball will come down back to the hand with. The second function will calculate the path that the ball will follow while it is being held by the hand, and then also calculate the path that the hand will follow when it is empty. This might seem a little bit confusing, but to give you an idea, this is a diagram of what the different paths are that are followed for throwing one ball in one hand. So the red path is the path that is followed by the hand while it is holding the ball. The blue path is the path that the ball follows while it's in the air, and then the green path is the path that the hand follows while it's empty. So the ball will be in the hand down here, it will move up, it will get thrown, and then the hand will be somewhere over here. The ball will continue along while the hand moves along this green path, and then eventually they'll both meet up where the blue and green paths intersect, and then the ball will be in the hand again, ready for the next time around. So this second function will calculate the green and the red paths here. The third function has the role of splitting up this red path into a path for the hand and a path for the arm, because those are 2 separate components in the way that I have designed Jugglebot. It's a little bit confusing to go into detail with this right now, and I'll go into a little bit more detail a little bit later in this video. But yes, I'll just leave it at there for now. The fourth function needs to calculate how long all of the legs need to be to move the platform into the correct place such that it follows its segment of this red path. So say the arm needs to follow a path that looks like this. This fourth function will figure out how long all of the legs need to be so that the platform actually follows this path. And the last function is arguably the most important, which is a safety function, just to make sure that none of the legs are commanded to move to be too short or too long so that they break themselves, basically. Yeah, so that's a pretty important one, and I will absolutely need to have that in before I start doing anything serious with Jugglebot. To give you an idea of what I've already done and what I will be doing over the next coming days and or weeks, depending on how long this takes, I have currently got these first two functions, so I can plug in some catch and throw position and whatever throw height I want, and it will calculate what velocity the ball will be coming in with if it's a catch, and what velocity the ball will be going out at if it's a throw. That one's relatively straightforward. So the second function that I've done is to calculate the path of the hand while it is holding the ball and while it is empty and returning to the next position where it will catch the ball. This was a little bit tricky to do in Arduino, and I'm still not certain that the way that I've done it is the best way to do it, but I've essentially got it so that it's outputting an array of X, Y, Z positions. So we've got X, Y, Z all the way down, X, Y, Z, 1, 1, 1, down to the bottom. And my thinking is that when I go to move the motors, I can just say, grab the next position from this array as we move down in time. And so those X, Y, Z positions will look approximately like dots all the way along here. I've currently got it set to generate 50 points, and that seems to have a pretty fine resolution between each subsequent point. There's not much of a jump, so I think that should be fine, but I'll have to wait until I actually test moving things to see how many points I need to make a smooth path. Unfortunately, I can't think of a really good way of plotting this data from Arduino to verify that what I've done here is actually correct, but what I have done is I can compare it against a different plot that I've generated in MATLAB, and just by qualitatively looking at them, I can see that they're pretty similar. So what these plots represent is the change in the horizontal position and the change in the vertical position. So the green line in these plots is how much the hand moves up and down. So you can see it starts at 0.3 meters high, it's relatively arbitrary at this point, and then it goes down to about 0.15 and then back up to 0.3. While in the X direction, it starts at negative 0.1 and works its way up to positive 0.1. And because these two are pretty much the same, they look the same, I can be pretty confident that my Arduino stuff is working the way that it should. If you're interested in what this path actually is, they're called Bezier curves, and I'm using here what are called 4-point Bezier curves. So this is the same thing again, but here I've just shown sort of the infrastructure behind what's generating these curves. So you can see the red dashed lines and the green dashed lines are the sort of control points that are used for generating these curves. If you're interested in knowing more details about this, I'll put a link in the description for the website that I used to get most of my understanding of Bezier curves. And yeah, they're pretty cool. They're definitely interesting to play around with. But anyway, so that's what I've done so far for that function. So that will output the path that the ball will follow while it's being held, as well as the path that the hand will follow while it is empty. My next steps, I'm not too sure which of these two functions I'm going to do first. I think I'll probably do the second one, where I will calculate the leg positions so that the center of the platform will follow the path that I want it to. I think I'll mostly just do that because I already have all of that code written up just in a different program. I just basically need to copy it over. So it shouldn't be too tricky, I don't think. As for this first function here, breaking the ball path into the hand path and the arm path, I'm actually not 100% sure how I'm going to do that yet. The general structure of this is that the arm path can be whatever I want it to be, but the hand path relative to the arm path can only be a straight line, because the way that I'm designing things is that the hand can only move straight relative to the path that is being moved around by all of the legs. So this means that I'm essentially going to be decomposing this red line here into a smaller version of itself and then adding on a straight line at every given instant, which will represent the hand relative to the arm. I'm still not exactly sure how I'm going to split these up, and I need to do a bit more thinking about that. But that's the general gist of how that will work. And then the last function, the safety one, my thinking is just to have a final check. So every time before I send any information to the motors to actually move it, this last function, the safety one, will take in those numbers and say, yeah, these numbers are good, no actuators are going to kill themselves, so go ahead. Or, no, these numbers are bad and I need to cut them off, and it will either stop the program or it will just cut the values off at the limits. And finally, to see how all of these functions will relate to each other and how this will actually achieve this goal that I stated at the very beginning, here is how all of these play into each other. So at the very beginning, I'll be putting in some variables that I just basically choose somewhat arbitrarily. And those are things like the catch position and the throw position and the throw height. And then through these 5 functions, we will end up with the positions that the legs need to be in to actually achieve that throw, as well as a safety function to make sure that nothing dies. So at the end of the day, I'll be able to put in the throw height and I will get out movement for the legs. So this will hopefully achieve what I want. So that's a relatively detailed look at what I've done over the last week or so and what I will be doing in the next couple days or weeks. And hopefully it all works. Hopefully it can all run on the Teensy that I've got. I only have real rough plans of what I would do if it can't run on the Teensy, of like getting a Raspberry Pi that will send commands out to the Teensy. But it would be pretty nice if it all can just run on the Teensy. So fingers crossed. There's also, of course, going to be a lot more coding that will need to be done as this project develops further, but this should be enough for me to tell Jugglebot to throw a ball in a given path and have it work. So again, fingers crossed. It's definitely going to be interesting to see how well this works. And yeah, as always, I hope you found this interesting. And if you have any thoughts at all about anything that I just went through, then please let me know. And I will see you in the next video. Have a good one.